G'day guys, Cam here battling away in the workshop today. Well, not actually in the workshop, we're in the back office at the moment. Before I start, I'd just like to say thank you to all those people that have subscribed to my little show. I put this little YouTube channel together mainly to give me some motivation to actually go ahead and do some project work in my shop and record it as I went. As I said, it's a bit of a motivational tool just to keep going and watch the progress as I go. So I'm really chuffed to see people looking at what I'm doing. So thank you for that. Thank you. I really appreciate it. Another thing I'd like to do is give a shout out to a guy called Warren Turner. Warren's one of my subscribers, and Warren looked at that description I did on that little multi-tool, that little lathe tool, and he's actually gone out and made one based on that description. That's the little tool there you might remember. Little diamond headed tool, and he sent me a couple of photographs of what he's done, and I must admit I'm absolutely chuffed to see somebody taking a description like this and making it their own, and he's done a fantastic job with it. So kudos to you, Warren. Great job. So there's the little locking pin. Alright, that's the lathe slotter we're at the moment. We've done all the sideways, milled in the dovetails, dowel it all in position, put the bridging plate across the top. So you know that's coming along very nicely at the moment. I'm really happy with the progress on that, but we're going to give this a rest for a week or two. I'm going to do a little series on something I used to do an awful lot of years and years ago, and that's pattern making and casting. So I can't actually do the casting because I haven't got my little foundry set up at the moment, but I'm going to do a series on pattern making, and I was inspired to have a look at getting back into doing some pattern making by watching Emma at Emma's spare room. So any of you who watch her videos know that she's doing a little Henry Greenley designed Stuart Turner hit and miss engine, or a little gas engine, and she's doing the patterns and the core boxes for that little job at the moment. And anybody who's done pattern making knows just how hard it is and how it does your head in, particularly when you start introducing cores to, particularly when you've got to get those core pricks to line up with features exactly where you want to put them inside a casting. So she's doing a fantastic job, and I'd encourage you to go and have a look at the progress and look at how she's going about that. So it sort of gave me a little bit of pattern envy. I was looking around for a little project that I might be able to do for a pattern, just to do a description on YouTube, and I emailed Emma and asked her if I could have some dimensions or some details on that flywheel. There's a beautifully curved flywheel that she's got as part of that set, and she sent me down a description with a drawing, which I'll show you. And she's also sent down some dimensions with that as well. So we're going to do that as a project on the screen. I've got some screen capture software we're going to try. We're going to be using Autodesk Inventor 2016. It's a student version that my son uses from uni. So I've snatched his laptop so that I can do that. Once we've finished that design, we'll then put that into a CAM program where we'll do our tool paths and our coding. Once we've done our coding, we'll put that onto the CNC 3-axis router, and we'll actually fully machine out a little flywheel pattern set. So looking forward to doing that. It's been a long time since I've done any pattern making. It's been quite a while since I've used Inventor. As a matter of fact, it's over 3.5-4 years ago since I really used it. It was part of my job for. I guess I used Inventor for nearly 15 years. It was part of my job doing special machine design, process and production line design. So it was a program that I used fairly extensively. So that's what we're going to use for that. Pattern making for me came about when I started casting, obviously when you're going to do casting, you need patterns to shape what you want to cast, and I started off with a little backyard foundry, as a lot of other people have. And if you've ever watched Chirpy's Tinkerings and his little backyard foundry, it's hands-on, simple, fantastic backyard casting, and I love sitting back watching what Chirpy does in that little foundry. I sort of reminisce a little bit about what I started out as, and what I started out as tended to grow into a fairly large foundry that myself and a good mate of mine ran as a part-time business on a large block, and had a big block with a fairly large shed on it that we put an outrigger onto, that we set up a foundry in, and towards the end we were casting up to around about 25 kilo of iron, and we could do over 100 kilo of aluminium in one pour out of the pit furnace. And with the iron we were running that with an oil-fired furnace, and prior to that we were running it with a coupler. And the coupe we could put out around about 12 to 13 kilo of iron every 6 minutes, and we increased that capacity. We lifted the slag hole up to give us a bit more capacity inside the weir, so that we could get that up to around 15 kilo every 6 minutes. We could charge out of that. And I can tell you, after running a coupler all day, you were pretty stuffed. It was hard work. It was a continuous caster. Once you had it up and running, you kept it running. And there was a lot of pre-work, getting all of your moulds pre-rammed up, so the whole paddock was just full of moulds the day prior, and out we go and we cast them out. So, but towards the end, it was long hours on the weekend, 12 to 14 hours on a Saturday and Sunday, and then doing a full-time job during the week, and doing pattern design and machining after work. And it started to get very laborious, and something that I absolutely loved and enjoyed looking forward to was doing my backyard casting on the weekend. When it sort of became bigger than Ben-Hur, it became something at the end I guess I hated and loathed and didn't look forward to going to do. And I must admit, I take my hat off to people who can take a hobby and turn it into a business and enjoy it and make a living out of it. But for a lot of us that maybe take a hobby and think we're going to turn it into a business, and that business then has to put food on the table, has to pay your mortgage, your rates, your gas, your electricity, it soon becomes an absolute chore. So take my hat off to people that can make it happen, but yeah, when it starts to become something that you need to live from, it gets very, 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 very hard. So yeah. All right, I've got some examples of some castings that I used to do, and pattern making. So as I said, making patterns by hand for me was very laborious, and we used to do some of these little blowers. So that was the one half of a pattern for the casing, and that was the fan blade. I dug this out of a box I haven't seen for years, but that was the blades. And people ask me, how thin can you cast aluminium? Well, you know, these ones here, we're down to 1 millimetre thick, and you know, nearly 2 inches, 50 millimetres in depth. So we actually used to add a little bit more silicon into our aluminium, and I can tell you what, trying to put silicon into molten aluminium is like trying to dissolve sugar in cold water. Very, very hard. The patterns there for the casing, so yeah, we knocked out a lot of these over our time too. We used to do loco plates, steam loco plates. I did a set of plates for the Puffing Building Society years ago for G41, the Bay and Peacock Garrett. So, but we used to do an awful lot of loco plates as well. So that was doing patterns by hand, and as I said, I take my hat off to Emma for what she can do there. It's absolutely brilliant. It does my head in if you can do those by hand. I'll show you an example of some of the patterns that I've done by hand. I know for those little Zenith updraft carbies that I did show the trial patterns or the trial castings that I did. And I actually saw a set of them on a Ronaldson tipper tractor up at Lake Goldsmith, a big steam rally I went to last weekend. So I was absolutely chuffed to see my castings that I'd done. I did a run of 25 of these sets for a bloke, and I was absolutely chuffed to actually see it on one of those old Renaissance tractors. So I'll show you some photos of those handmade patterns for that casting set, and I'll show you the castings actually on the tractor. So have a look at these. Well, as I said, I used to make them by hand, but as I said, that got very laborious, so I built a 3-axis CNC router back in 2004, 2005. That was when CNC was just sort of starting to come in as a hobby in its own right. And this was a pattern. I've shown these before. This is the sort of hit and miss engine that I designed based on the Rosebery. So that was a set of patterns, and that's one half of the core box that I did. So that core's all done in one to stick into the sand mold to pour out. So that was all fully CNC machined. So as I said, we're going to give the little slotting attachment a bit of a rest for a few weeks while I do this little series on pattern making, and we start off with the actual design. And as I said, I'm using Inventor. When you're doing pattern making using a program like Inventor, it becomes more like sculpting, more so than traditional design, which is what I use it for. So there's a little bit of toing and froing on this, and sometimes you'll do things and the unexpected happens. It's a little bit fickle in that way. You have to sort of set your ducks up while you're doing this particular job, because it can fall over and you've got to backtrack a fair bit and look at another way of doing drafting and filleting and some of the functions that go into that. So we'll step into it. As I said, I haven't really touched Inventor for quite a few years, and the CAM program I haven't touched for a lot longer than a few years, so it's going to be a bit of a learning exercise, and we'll see how we go. So sit back, enjoy it, and we'll see where we end up. It'll be a bit interesting anyway, so we'll make a start on that. Right, hi guys, we're back again. I apologise to everyone who started watching this video last night, but K Audio messaged me and said that the quality was pretty poor and hard to see, and I must admit I have to agree with him. So this is my third attempt at doing this screen capture program. I was out in the shed the first time. It was a cloud-based program that I was using, and my internet kept dropping out, so I had to give that one up, and then came inside and did the second one. But as I said, it was pretty poor quality, and my son has just set me up with a program that he uses at uni. So I've got a whole heap of commands down here written down, hotkeys to use, and we'll see how we go anyway. But hopefully this is going to give us a much better quality show. All right, let's make a start on this curved flywheel. So I've created a file. We just call it Emma's curved flywheel. I've got some base dimensions that I've got for Emma, so we'll use those to start with. Now, with any parametric solids program, whether it be Inventor, whether it be Pro E, whether it be SolidWorks, there's a myriad of them out there at the moment. We always start off on a sketch plane. Well, 99% of the time we start off on a sketch plane. We can bring in solids, STL files, IGS files, and we can actually start creating sketch planes on the solid surfaces on those items. But 9 times out of 10 we're starting out of scratch. We're going to start off with a sketch plane on a work plane. So we'll just click on that, and it brings up 3 options for our work plane. So we've got our front elevation, side elevation, or we can start off in the plan. And I always default into the front elevation. It's just something I do, just something the way I roll. And the first thing I'm going to do is the outer rim diameter, and Emma's got, I think it's 148. Well, I'm going to make that a tad smaller. We'll make that 140. And we'll do our inner rim. let's make that about 110. We can change these at any time throughout our modelling. We can go back into the features and we can change the thickness, the diameters. We can change everything as we please, and that's where we sort of start sculpting a little bit to get the shape the way that we want it to be. We'll put an inner hub. We'll start off at 25mm and we'll see how that goes. So we've got our base components for our flywheel. So we've got our outer rim and we've got our inner hub, and we're going to create that as a solid. So we're going to put a bit of meat into that. So we're going to extrude out those shapes. So our inner hub and our rim, and we'll do that at 28mm, which is what Emma's got on her little description there. And we've created a solid to start with. Now we've got some surfaces here. We can start putting features on surfaces if you're building up as a machine component or whatever you might be doing. But in this particular case, I want to start sketching out the curved spokes. So I need to create a new work plane that I can create a sketch on. So we'll just create that new work plane right smack bang in the middle here at the moment. So I'll just quickly do that new work plane. And as you can see, that new work plane cuts it in half. And that's what we're going to create a new sketch on, which is what we've done. Right, once we've got a sketch plane on, we can transfer shapes or outlines from our solids components or another sketch onto our new sketch surface. So we can do that by doing it as a project entity, and this will start giving me some structure to start working to. So we'll do that inner hub, and we'll do the inner rim as well. So you can see that's gone in green, those lines. So we now have some line work down on our new sketch plane. Setting up little datum points to start working, and I like to use points. So if I'll bang a point on that rim, doesn't matter where it is, it can be anywhere you like, and we'll pop another point on that inner rim there. Now if we have a look at that, we can move those points around. As you can see, we can drag them and move them around that rim. We can put them wherever we like. They're not constrained, and in sketching we like to have things constrained, and I'll show you a little bit more about that as we go. So at this stage I'm going to constrain those points horizontally to the center point of our hub. I want to mention before, this isn't a tutorial on how to use Inventor, it's how I roll with it. You can put 5 or 6 people into a room that are experienced Inventor users, and they'll all go about modelling differently, but there are a couple of hard and fast rules that we like to stick to, and we'll go through those a little bit as we go as well. So let's set up some horizontal constraints for those points. So if we grab that and pop that in there, you'll see that goes down into horizontally, and we can't grab that point, we can't move it, and we're going to do the same to the other one. So those points are now constrained, they're locked into our geometry, we can't move them. Right, from those I'm going to use that to create our arc. So I'm going to grab our arc, and I'm going to go from start point at that point to an end point on that point, and then we're going to give it a radius. So I'll start off with a radius of 50. Now if we have a look, that arc is now in blue, that line work is in blue, which means that it's fully constrained. We can't grab that and move that around. It's locked into our geometry and it's locked into a dimension. Right, we'll give our curved spokes a little bit of width. So we're going to offset that arc, and we're going to move it up to wherever. Now if you have a look, this has gone in maroon. That means that we can grab that line and we can move that wherever we like. It'll still remain as an arc, but the radius will change and the position changes. Now that is not constrained, and we need to put in some dimensional information to constrain that back. So we're going to put a dimension in here, and we'll give this spoke a width, and let's start it off at 8. We'll see how that looks anyway as we go. Right, another thing I want to do is put in what I call a rail. So with any of these parametric solids modelling programs, you want to think a couple of steps ahead and start setting geometry up for sketch planes you may want to create, or geometry you may want to create down the track. So in this particular case, that's exactly what we're going to do. So I'm going to pop a line in that is going to be at right angles. It doesn't have to be at right angles, it can be anywhere along here, but just for convenience sake I'll stick it in as right angles. So as you can see, we've got that line in there, and he's nice and blue because he's constrained at 90 degrees, and we've given that a length. What I want to do is trim that back to our spokes. If we have a look at that too, that's now gone maroon, so we can grab that and we can move that around, and we don't want to do that. We want to constrain that back in, so I'm going to constrain that back in with a dimension again. I'll do it that way. So I'll give it from the center point out to there, and we'll give that a dimension. And you can see that's now gone blue. It's now fully constrained, it can't move. Now, if we don't constrain sketches, and you might have been working on a model for a few months, or building up a machine, all the componentry, and somewhere down the track you have constrained a sketch and something has moved, and it throws everything out. You'll get errors coming up all over the place, and it is an absolute pain to backtrack weeks of work to try and fix up an issue, and sometimes it can be really laborious to fix that problem up. So I do myself a favour, I make sure my sketches are fully constrained before I move them into a solids base. Right, now as I said, we've now got some geometry, and I'm going to set up a new work plane that I'm going to create a sketch on to start doing the shape of our spokes. Before I do that, there are a couple of simple ways that we can do this. If I was to extrude, I can't extrude that shape just yet. I can extrude that out. I can lock that in on the ends, extrude that out, and create a rectangular type spoke, and then fillet it to smooth it out. Is one way that we can do this. But I'm actually going to do this with an elliptical type spoke. I was up at Lake Goldsmith, as I mentioned a little while ago, and I was having a look at a lot of the curvy spoked flywheels up there, and they are an elliptical type shape, so we're going to do the same with this one here. Because we're going to do an ellipse, I'm going to do what's called a sweep on this, which means I'm going to project that shape along a line to create that spoke. So I need to put in what I call a rail. So before we actually put that new sketch plane in, I'll just do an offset of this. I'll stick it up here. Okay, then we'll put a dimension in, which is 1/2, which is going to be 4mm. So that's going to be smack bang in the middle. And if you have a look, you can see the tail actually runs into the solid. If I highlight it there, both into the hub and into the rim, and I want that to extend through a lot more into that solid, and you'll see why I want to do that a little bit later on down the track. So I'm just going to put a line in here. Doesn't matter where it goes. And I'm going to extend that rail into those lines. So if we have a look now, if I highlight that rail, you can see it extending well into the solid. Right, let's create a, finish that sketch out. Let's create a new work plane. So I'm going to do that now. I want that to be at 0 degrees. So if we have a look at that, you'll see that we've now created a new work plane to start our new sketch operation on. So we'll create a new sketch on that work plane, and that moves around. And what I'm going to do is project that geometry that we created in the previous sketch onto our new sketch plane. So I'm just going to project that across. So we now have some geometry that we can work with. I'm going to create an ellipse just in here. So green means, in this particular case, it's snapped to the midpoint of the
the line that we just projected over, and we're going to go to that outer edge of that line. I'll just stick it in there. Once again, you can see that's gone in the maroony colour, and we can change that around or whatever we like, which is not good. It's not constrained. We want to constrain that into place, so we're going to give that a dimension so we can actually lock it into place. Let's start off making that 3mm. So we've now created the shape of what our spoke is going to be, and now we want to sweep that around to follow that curve that we've created. So we'll finish that sketch out and we'll go up to our sweep command. I use sweep commands when I'm doing platforms or ladders or stairways. Create a shape and a sweep rail to create handrails. A very quick and easy way to do it. So let's highlight the shape that we want to sweep, and then we have to give it the path or the rail that we want it to follow. So we'll just click on that. Okay. Now that's now created our first spoke. Right. Looks a little bit spindly, I think. We might be able to put a bit more curvature into that, but what I'll do, let's create the 5 spokes around here, and then we can modify and we can start caressing this a little bit to give it the shape and size that we want. So I'll do a circular pattern for that. So I'll just highlight the shape that we want to work with. We'll give it an axis that we want it to revolve around, and we want to do 5 spokes, 5 instances of this spoke. Okay, that's let's just have a look at that and see how that looks. Yeah, I think that looks a little bit too spindly. So what we can do is we can go back into our sketch plane of our sweep. So I'll just grab that, and I'll leave it at 3. We won't do that just yet. I might go in and make this a little bit thicker. So going back to one of our previous sketches, and as I said, we can go back at any time and change any of the parameters that we put in. So let's try that at 10. Change that to 5 for our rail, and we'll finish that 2D sketch. And as you see, that now updates. I want to have a look at the shape of what that flywheel is looking at, what the ellipse looks like. So I'm just going to have a quick look at that. So I'm just going to do a cut section on that, so we can have a bit of a look at it. So we can see the shape in there, and I reckon it's looking a little bit too flattish. I think we might thicken that up a little bit. So let's go back into our ellipse. At the moment I've got that 3mm thick on the half, so that's 6mm total. I might let's bump that up to 4mm, which is 8mm total thickness when the spokes are together. Now let's have a look at that. Doesn't matter which way we look at it. That's looking better. It's a little bit beefier. Let's see how our spokes are looking. I reckon that's looking a little bit better. A little bit better shape, but a little bit more meat on them, I think. We'll leave those spokes at that. As I said, we can change them. Now look, I might make them a bit curvier. So we'll go back to this initial sketch. I want to put a little bit more curve into those. Let's try it at 45. I think we can go a little bit more. So this is where we're sort of using our eye a little bit to get a shape that we like. Looks a little bit better. Right. Excuse me while I have my coffee. Can't start a day without coffee. Alright, let's start putting some features in on this rim now. So it does have a step down, and I do go back into Emma's photo. It's not a big step down, it's not a big shape in that, but what I'll do is we'll go back to our 3D modelling. We'll now create a sketch on that solid's face. This is what we now have. And we can start sketching on that. So I'm going to put a circle in. Let's go back to our face. I'm going to put a circle in, and I'll put it in 120 just to start with, and we'll see how that starts looking anyway. Now I'm going to project that inner rim down to give us some more geometry onto that sketch plane, which allows us then to extrude that down. So we're going to extrude it, but we're not going to extrude it out as it shows up there. We're actually going to cut it in, and we're going to give that a depth to cut in. So let's make that 5mm, and we'll see how that looks. I think that can go in a bit further. So let's take it in 7mm and we'll see how that looks. That's better. Now what we can do is we can mirror features that we have here onto the other side. So we can go up and use the mirror function here. We can grab that feature, we can give it a mirror plane, which is that fella there, and we can go OK. So that extrude cut is now on the opposite side. And if I was to go back into the original and change that back to say 2mm, if we revolve that around, you'll see that that has also done the same thing. If we don't want that to happen, we can create a new sketch plane on the opposite side and do it in its own right. But, we'll go back to 7. Right. To me, that flywheel just looks far too thick. So I think we might go back to our original extrusion, and let's cut that. Let's go back to 22 and we'll just see how that looks. Right, we just need to change our step downs on here. Let's take that back to 5 then. Right, let's just have a look at the shape and the thickness, and I reckon that is looking quite a bit better. And as I said, we can go back to any of the sketches and we can change that geometry whenever we like. So for example, we say, look, let's put a little bit more meat on for machining. So let's allow a 5mm machining allowance. So let's increase that outer rim out another 5mm. Finish the sketch, and up. There she goes, she updates. So as I said, we can come in at any time, we can change that geometry. We can sculpt it. And that hub, I reckon, looks a little bit too big too, so I think we might go back to that original sketch plane there, and we might knock that back to, let's go back to 22 and see how that looks. That looks quite good. Put a bit more curve into our spokes as well. Move that back and just swing that around. So I reckon that's starting to look pretty nice. It's got a pretty shape to it. It's got a nice curve. It's got nice lines on it. Now what we need to do is start doing some filleting. No, we won't do the filleting just yet. What we will do, it's one of those things, you've got to look at what feature I'm going to put in before I do another feature. In this particular case, with any pattern, we want to have draft. And I want to create the draft on this so that we can draw it out of the sand. Before I do that, I'm going to make a copy of this to become the backside half of the pattern. I'm going to use this for the front side, so I'm just going to go in here and just do a save a copy as. Okay, So we're going to call this as flywheel. I'll call this part 2. And we'll save that. Right, what I'm going to do now is I'm going to split this in half because this is going to be a split pattern. So let's do a split. So we can come up here, create a split on that. That's the entity that we want. You can see it all highlighted in the pink there. And we need to give it a plane that we want it to split through. And it's saying it's going to split it from the plane back, which is what we want. We'll OK that. So we now have our split pattern. Alright, let's start putting some fillets onto this. Now obviously when we've copied this, we've lost the connection between the two, so they're now two totally separate halves. We can do that differently, but I want to do a couple of different things on this. One thing I might do before we start is, this is the one that's going to be up close to the engine, that's going to be rubbing up against the spigot. Probably want that sitting out a little bit further, that hub. So there's a couple of ways we can do that. We can create a new sketch plane, project the entity and extrude it, or we can just go and do what we call thicken onto that face, and I'm going to give that another 3mm. Okay. Once again with that I'll just show you, on thicken we can actually do that as a, why don't we do it as a negative? So it's been a while since I've used this here, so we have to come back in here. We'll give that 3mm, but we'll give it a negative cut in, so we can actually remove material like that. But we want to add some material on, so we'll thicken it in the positive direction of 3. So we can see that that's now sitting proud of our rim. Right, let's get some draft put into this, so that we can remove it out of the sand. So we have a draft command up here, and we need to give it a pull direction, and I always give it the pull direction of the actual plane. And we can select the faces that we want to draft, and they have to be in the same plane to start with for these ones. And the pull direction looks okay. We'll okay that. We've got to put some draft on the outer rim of this, so we'll draft that again. Select the rim. That has done it in the right direction, and the inner hub we want to put some draft on that as well. So once again we'll select the pull direction, select the face, and that's going to draft out for us quite nicely. So we've now got draft put on all the faces that we need to have put on this. And when you're doing cores and you need to put draft on cores, and some of the cores that I've done in the past are very intricate, and it's very easy to forget a face. So we can come in and do an analysis of this and actually check the draft before we move on. So we can come into inspect, and we can select draft, and it brings up a color palette. So 0 draft is in red, going out to green, which is a positive draft, which means that we can draw it out of the sand easier, or down to blue, which is a negative draft or an undercut. So we give it a pull direction that we're going to withdraw it out, and we'll go OK on that. If you have a look, that's all in green, which means that that will be able to be removed from the sand very easily. If we were to change, let's just select one we can see easily. If we were to change that, and I was to change the pull direction, I'll go OK. You can see that's in blue. So what that means is that that is an undercut, and that is going to drag our sand out, which is what we don't want. So we want to go back vice versa. If we just made that draft angle, we made it 0.01 because we can't have a negative draft. You'll see it goes red, which is basically 0 draft. So we'll go back to where we were. Right, so we know that we've got the draft right on this, and now we can start putting in some fillet features. If I put the fillet features in before I draft, sometimes it doesn't work because the face does change where the fillet has been put in, and it goes a bit astray on us. So we'll go back to our 3D modelling. We'll select our fillet command, and these ones that connect up to our rim, we'll make them 3mm, and we'll just see how that looks. Okay that, and we'll do the one up to the hub. So we'll select our fillet 2, and we'll select that. So it doesn't look too bad, I don't think. That looks quite good. So what we'll do is we'll circular array those features. So we'll select the 2 fillets that we've just done. We'll give it the rotational axis that we want it to roll around. Once again, we're going to do 5 instances of these fillets, and away they go. Now, as like before, if we go into any of those fillets and we change it, let's change it back to 2, it updates all the other fillets that we've just put in. So I'll put it back to 3. Okay. Right, well that's basically our pattern, or this half of the pattern completed. There's another function that we can do, and I'll show you next time we come on here, and that's called deriving. We can do a derived component, and that's where we can do subtraction. So if we're doing core boxes, we can create this as a positive. We can put it into a box and subtract it, and instantaneously create our cores to machine. Great thing with this is too that I can go and derive component, and I can scale it. So I can scale that up. For example, let's just say we're doing these in aluminium. I can scale it up 1.8% to allow for the shrinkage factor of that aluminium. So very, very versatile for doing dies and patterns. And it's got some fantastic features on it. And I've had a look at the Fusion 360. Very, very similar features. So I've had a good play around with that. For me, that's cloud-based, and if I take this to work where I work, which is a bit remote at times, I don't have an internet connection. So because it's cloud-based, Fusion 360, just to sit down and have a fiddle during smoke hours or lunch, I can't do that. Whereas my son's version here that I'm using at the moment, the student version, if he lets me keep his laptop for a few more days, I can finish these off. So what I'm going to do is that other half that we created, we're going to go through the exact same structure to create the second half. So I'll do that off screen, so to speak, to create that. So that'll create our 2 halves. Then we'll put it into our CAM program, and I'll go through setting up the machining operations for that, and then coding to get that to be read by our CNC machine. There's something I might do now. I did have customers in the past with our foundry ask, can we put in logos or pattern numbers or drawing numbers onto the faces, so that if it has to be replaced, it's very easy to go back and get a pattern, or go back to a drawing that was created from, and we can do that fairly simply. Well, not fairly simply, there is a little bit of work in it, but I need to create little core prints off the rim, and then create a core box with matching shape, as what we've done with the core prints, and then I create either lettering or a logo that goes with that little core box that we can do our hard sand in to create our little emblem or our lettering that we want to have cast into that rim or that surface. So what I might do is I might actually do that. I might come back next time we look at this. I'll set all that up first, and we'll go through iteratively each step that we go through to create that those prints and that core box. And as I said, it's very simply going through derived components to create a core box and come up with our final shape and our final lettering or our logo. So we might do that next, but yeah, just for now I think we'll leave it at that. We've got a nice shaped little curved spoked flywheel that would go on that beautiful little Stuart Turner engine that Emma is doing. What was described by, I think it was designed by Henry Greenlee actually. So we might leave it at that for now. As I said, I'll do the second half. I'll just quickly put that together. When we do come back, I'll show you this as an assembly as the 2 halves together, and then we might have a look at those, doing little claw prints on here to put some emblems in, or some writing into that rim. Alright guys, well thanks for watching. I hope that wasn't too long-winded, and we'll come back with the next stage very soon. Okay guys, see ya.